In the last section, we finished up with our deal function. Now we have completely skipped over shuffle right here, but shuffle is actually going to be a little challenging, and so that's something that we're going to come back to a little bit later on. So for right now, we're going to take care of this next function, which is save to file. The intent of this function is to take a deck and somehow save that deck or a representation of that deck to the hard drive on our current machine. Then at some point in the future, we should be able to call new deck from file, which will load up that file from the hard drive and create a new deck or a new list of cards. So anytime we start thinking about working with the underlying hardware or the underlying operating system that our program is running on, we need to instantly start thinking about making use of Go's standard library of packages. So let's pull up Go's standard library of packages. We'll take a look at some of the documentation and we'll try to find a package that might help us achieve saving something to the hard drive and then later reading that file off. So in a new tab inside my browser, I'm going to pull up the Go standard library documentation. I'm going to navigate to golang.org, and then on the page that pops up, I'll find the blue packages button right in the center. Now this is a list of all the standard packages that are included with Go. We're going to be looking for a very specific package called IOUtil. So I'm going to do a search on this page for IOUtil. And here it is right here. The IOUtil package is a very small package that implements some very common operations for working with the underlying hard drive on our working machine. So I'm going to click on IOUtil right here and take a look at some of the documentation around it. If I scroll down a little bit to the index section, you'll see a list of all the different functions that are included inside this package. And so one in particular looks kind of interesting to me. This one right here called write file. So I'm going to click on the write file function and we'll take a glance at some of the documentation around it. The write file function is used to create or write to a new or existing file on our local hard drive. So take a look at the argument list here. The first argument is named file name and it is of type string. So in other words, this function write file expects us to call it with a first argument of file name, which is a string. I bet you can imagine what this argument does. It specifies what the name of the file that we want to write to is. The second argument inside of here, which is labeled data, again, kind of a self-explanatory argument. This is the raw data that we want to write to this file on our hard drive. Now you'll notice that the type for data right here is listed as square brackets and byte. So remember, anytime you see square bracket right here, we always want to be thinking of a slice. And so this can be read as a slice of bytes, or what we commonly refer to this in Go as a byte slice. We'll talk about what this byte slice is in just a second, but before we do, just notice that there is a third argument on here of perm, which is short for permissions. And so this essentially says what permissions should we use to create this file if we need to create it. Okay, so back over to the second argument here of byte slice. So we're going to first talk about exactly what a byte slice is, and then secondly, and probably more importantly, how we're going to get one. So our goal here, in order to use this write file function, we need to somehow take our deck type, like that deck type, that list of strings that corresponds to the actual cards inside of our deck, and turn it into something of type slice byte. If we don't get something of slice byte, well then we can't use this function at all. The only way we can use this function is if we can pass into it a byte slice. So like I said, let's figure out what a byte slice is. All right, so diagram time. Here we go. Okay, so in very simple terminology, anytime you hear the term byte slice, I want you to think in your head of string, like a string of characters. So let's figure out how we can relate together a byte slice and a string. First off, right here on the second part of this diagram, this is an example of a byte slice. So it is a slice, remember a slice is like an array, where every element inside of it corresponds to an ASCII character code. So if we represented this with decimals, we would have, for the string hi there, 72, 105, 32, and blah, blah, blah. We can go to a website like ASCIItable.com and take a byte slice and turn it into a string. So I'm going to open up a new browser tab and navigate to ASCIItable.com. When I do, you're going to see this big old table appear on the screen right here. And so on this table, find the column labeled decimal. There's several columns labeled decimal on here. And then we'll look at this byte slice right here. We'll find the first element of 72, and then we'll take it over to this table and find the number 72 right here. So the decimal character 72, or the decimal value 72, corresponds to a character of capital H. And then if we take 105 right here, 105 corresponds to a lowercase I, and then 32 corresponds to a space. And so essentially this byte slice right here, all it does, it represents a string. It's just another way, a more computer-friendly way of thinking about a string. Now obviously for you and me, a byte slice is not terribly helpful, right? Like you and I can't really just glance at this byte slice right here, this array of numbers, and somehow figure out instantly what type of string or what actual string that corresponds to. And so usually for developers like you and me, we're always working directly with strings because these are human readable values. But many times, especially when we start working with the Go standard library, the standard library really just expects us to pass in a byte slice, which is the computer-friendly representation of a string. Okay, so hopefully that gives you a little bit more information about what this argument right here is. So we need to pass in a byte slice, or essentially a string. So now the question very quickly becomes, well, we have a dec type. How are we going to turn that into a byte slice? So let's take a quick break. We'll continue in the next section, and we're going to figure out exactly how we're going to take our dec type and turn it into a slice of bytes. So quick break, and I'll see you in just a minute.